Hey, hey, hey. 9.3 today. And guess what? If you can see just above me, ooh, the Pythagorean theorem right up there. Do you see that? Yes. So, little confession here. I love my wife to death. I was explaining to her the other night about something I might want to build. Little shade kind of shelter over our patio, maybe a pergola type thing. And I was drawing something for her where the roof kind of has an A-frame like that, right? And she asked, how would I figure out the length I would need of these boards? This board and this board, the two that actually make the A-frame. And we know what this is. This whole length is about 21 feet. So if you divide that in half, it's about 10.5 feet, 10.5 feet. And we can make that height whatever we wanted. Maybe, let's say, 5 feet. Okay? Now, she asked me, how can you figure out the length of that slanted board? Because the slanted board's going to have to be a little longer. And I looked at her and I said, honey, I will use the Pythagorean theorem. Now, to some people, that sounds really hoity-toity complicated, the Pythagorean theorem, but not to you. I'm excited about today because this is just, like, I promise you, you will use this at some point, the Pythagorean theorem. Right triangles are all over our world, and if you build anything in your life, you will probably encounter a right triangle, and you're going to need to figure out the length of the hypotenuse. The way you do that is by using the Pythagorean theorem. It's an easy formula, and the reason we're moving to this now, after talking about square roots and real numbers, is because this formula deals with exponents, squares, to the exponent power of 2, and square roots. So, let's talk about this. Okay, lesson number 1. The Pythagorean theorem only works with right triangles. The Pythagorean theorem only works with what? Right triangles. Okay, you've got to know that. But it works with all right triangles. Now, I've got some high schoolers that don't remember this or even have trouble when I remind them about this on how to do it. But it's not terribly difficult. You just follow this formula. Let me show it to you. The Pythagorean theorem is always a squared plus b squared equals c squared. Now, a and b isn't just any old random number. No, a refers to one leg of the triangle. B refers to the other leg. Let me see if I can make this a little smaller. I don't know if I can. All right. B refers to the other leg. And then C always refers to the hypotenuse. So leg, hypotenuse. Doesn't matter which leg you put in where here. But the C is always the hypotenuse. Now, what is leg and leg? The legs always form that right angle. The hypotenuse is always that big, long, slanted one on the opposite side of the right angle. Okay, so here, if this leg is 3, and this leg is 4, and this hypotenuse is 5. If we plug those numbers in, 3 squared plus 4 squared equals 5 squared, this left side should equal the right side. Otherwise, their diagram is wrong. Well, what's 3 squared? 3 times 3 is 9, plus 4 times 4 is 16. That reduces to 25, right? 16 plus 9. What is 5 times 5? 25. Does 25 equal 25? Bingo! Yes, it does. So, these can be the measurements of a right triangle. We call that a Pythagorean triple. But anyway, so, let me just give you a problem here. Instead of using theirs, I'll give you my own. All right? Right triangle, I tell you that this length is 3. This length, let's say, is 7. What is C? What is the hypotenuse? Where all you would do is this is leg, hypotenuse, so 3 squared plus 7 squared equals, now guys, a lot of times people first learning the Pythagorean theorem, they put a squared plus b squared equals c. That's not right. You've got to have c squared. So look what I do here. A squared plus b squared, a and b are the legs, equals c squared. Okay, let's figure this out. 9 plus 7 times 7 is 49 equals c squared. Okay, I'll get my calculator out here. 9 plus 49, now let's do that here real quick, 58. Now, if I've got 58 equals c squared, here's the part where you really need to pay attention. We're trying to get c by itself. We want to know what c equals. We have to get rid of this squared. We don't care what c squared equals. We don't care that c squared is 58. We want to know what c is. What is this length? To get rid of that exponent, I've told you this before, square root both sides. That square root, that radical sign, undoes that square, and now it's gone. All you have left is c there. But we've got to figure out the square root of 58. So on my calculator, I go like this. Second square, 58, enter. 7.62, I'll round to the second decimal place, just because that's what I like to do. 7.62. So, if you had a right triangle, and that one was 3, and that one was 7, this length up here would be about 7.62, just over 7.5. So that's how you find the hypotenuse. I'm going to do one more example just so you are confident on this. I'm going to zip right through it. But I would encourage each of you to write the Pythagorean theorem real big at the top of your paper when you do this assignment. Alright, 5, 4, what is y? Well, 5 squared, I'm going to skip some steps. I'm not going to write it all out here. 5 squared is 25, plus 4 squared is 16, equals c squared. 25 plus 16 is 41, square root of 41. Alright, let me show you what I did. 41 equals c squared. Now I'm doing the square root of both sides. To be left with just c, square root of 41 is 6.4. How did I get 25 and 16? Because I did 5 squared plus 4 squared equals c squared. That's a squared plus b squared. A is always the leg, b is always the leg, and c is always the hypotenuse. Now, you have graduated to the next level. Okay? Take a look at this example. What if you know the length of the hypotenuse and you're trying to find out the length of one of the legs? That's different. Look at this. In this picture, and I'm not going to read the whole thing, we know that this whole thing is 300 feet. That's the hypotenuse of this. Looks like a parasailing thing behind a boat. You ever done that? I haven't. 300 feet. This distance down here is 200 feet. One leg is 200. What is the other leg? The other leg happens to be the height above the water here. So, just like every other time, write a squared plus b squared equals c squared. Plug in the numbers you know. We know that c is 300. Now, don't just put 300. You better put 300 in for c. You're still going to have to square it. Alright? Okay, now we've got 200 for one of the legs. We're going to figure out this other leg. 200 squared is 40,000. 300 squared is 90,000. Now look at this problem. How would you get this 40,000 gone so we can just deal with the b squared? You just subtract it from both sides. So, subtract 40,000, 90,000 minus 40,000 gives you 50,000. Equals b squared. Now you would square root both sides to get just to b. and b equals the square root of 50,000, which is about 223.6 la la. That's about how tall, or the height you are above the water. 223.5 feet. Cool. Let me throw one more example at you, just so you know this for sure. And let me orient it like this for you. You know that this one is 8, and you know that this one's 10. What is L, that other leg? Well, a squared plus b squared equals c squared. Guys, this can go really quick once you got this down. Okay? 8 is a leg, so 8 squared plus L is the other leg, squared, equals 10 squared. 8 squared is 64. Plus L squared equals, what's 10 squared? 100. Subtract 64 from both sides. L squared then equals 36. Oh, hey, I gave you a really nice one here. I didn't even do that on purpose. Watch this. What's the square root of L squared? That's just going to be L. So those will cancel out. What's the square root? Got to do it to both sides. What's the square root of 36? It's 6. Hello. Yeah. Now, is there a reason I just put positive 6? I did not put plus or minus 6. Yeah, because this is a triangle, and you can't have negative 6 for a length of a triangle. Alright. That might be it, but let's just see what they're saying here with the converse of Pythagorean theorem. The Pythagorean theorem can be written as an if-then statement with two parts. If a triangle is a right triangle, then this will work. But the converse would be, if these numbers work out, then the triangle is a right triangle. So, what if I threw a triangle your way, and I just tried to make it up and guesstimate, and I was like, hey, this one's going to be 9, and this one's like 7, and this one's like 7.5, yo. Is this a right triangle? Well, if it is, watch this. Watch how quickly I can bust this out. You can do this too. 7.5 squared plus, excuse me, 7 squared. Okay, that was a squared plus b squared is this. Now I'm going to do the square root of that answer is that. If this was a right triangle, that hypotenuse would be 10. Well, is my hypotenuse 10 up here? No. This is not a right triangle because the converse of the Pythagorean theorem did not hold true. So they're going to ask you here, can 6, 8, and 10 be a Pythagorean triple? If you plug them in, does it work out? Looks like it does. Check. Can 10, 12, and 16? Plug them in. Does not work out. No. All right. 13 minutes for that. Man, I really hope you got this down. I will help you out along the way. Go back and watch any part that you need to brush up on. But Pythagorean theorem, from this day forth, may you always remember a squared plus b squared equals c squared. And may this never intimidate your mind ever again. In fact, I hope it's just pure joy and fun for you. Remember, A, B are the legs, C is the hypotenuse. Don't forget the squareds. Just use your math skills to figure it out. Plug those numbers in every time. Enjoy yourself.